Welcome to Math 100 Section 2.2. We're working on simplifying fractions today. Please start with a warm-up. So first one, we got a number divided by itself, that is always 1. Any number multiplied by 1 is always itself. And any number divided by 1 is itself. So these are some important properties to keep in mind about this lesson. We're going to be using these to simplify fractions. Now in part 2, we're determining whether or not these numbers are divisible by 2, 3, or 5. Now the first one ends in an even number, so it's divisible by 2. Add the digits together. 4 plus 8 is 12. 12 is divisible by 3, therefore 48 is divisible by 3. It does not end in 5 or 0, so it's not divisible by 5. So just 2 and 3 there. Now in 160, it ends in 0, which is even, so that's going to be a 2. We'll add the digits together. 6 plus 1 is 7. 7 is not divisible by 3. Therefore, 160 is not divisible by 3. But it ends in a 0, so it's divisible by 5. Now the third one ends in a 5, so it's not even, so it's not divisible by 2. 5 plus 1 is 6. 6 is divisible by 3. Therefore, 105 is divisible by 3. And then it ends in a 5, so it's divisible by 5. Now we're going to do the prime factorization of 198. A lot of different ways to do this. You can see it's even, so you can divide by 2. The sum of the digits is 18, so you can divide by 3. Doesn't end in 0, 5, so we can't divide by 5. But there's another way to do this. We can do 6 times 33. So any of those ways will work. 6 then is 2 times 3, and 33 is 3 times 11. So we get 198 equals 2 times 3 squared times 11. Now what we're going to be doing today is taking a fraction and producing some equivalent fractions. The fractions are equal, they mean they have the exact same value. We're just going to change what they look like. So here's some examples of equivalent fractions. Alright, if we have a jar of red and yellow beans, and 2/3 of the beans are red. So that means for every 2 red beans, and I didn't color in the yellows, just pretend the white's yellow. Means we have 2 beans for every 1 yellow. 2 red beans for every 1 yellow. And we're going to keep that same ratio. So here, we just have 2 of them. 2 reds, 1 yellow, 2 reds, 1 yellow. So add them up, we get 4 reds, 2 yellows. Over here, we got 3 of them. So add these up, we get 6 reds, 3 yellows. The reds to yellows always stay in the exact same ratio. So what we can do is create fractions representing the number of red beans out of the total number of beans. So this is 2 out of a total of 3, so this is 2/3. This is 4 out of a total of 6, so that's 4/6. And this is 6 out of a total of 9, so that's 6/9. So that means all 3 of these fractions, since they have the same ratio of red beans to yellow beans, are going to equal the same value. 6 over 9 equals 4 over 6 equals 2 over 3. So those 3 fractions, they look different, but they have the exact same value. So that's what we're going to be doing today, is changing fractions, what they look like, without changing the value. All right, your turn number 1. Let's figure out which of these 2 fractions are equal to each other by creating pizza diagrams. So draw a pizza diagram representing 1/3, 2/6, and 3/8. And we will see which ones are equal by examining the diagrams. There's 1/3. Cut the pizza into 3 pieces. 1 is highlighted. All right, here we're going to do 2/6. So there's 6 pieces, and I'm going to highlight 2 of them. It helps if they're in the same position, approximately. Now 3/8, we're going to cut this one into 8 pieces. And it's like 3 of these. So if you look at these 3, they're pretty close, but these 2 appear to have shaded the exact same portion of the pizza. Whereas this one, it ends up being a little bit bigger. Not that much bigger because my artistic skills are terrible, but that one's just a little bit bigger. So the 2 equivalent fractions are 1/3 and 2/6 because they represent the same portion of pizza. So it doesn't matter if you cut the pizza up into 3 pieces and take 1/3, or if you cut it up into 6 pieces and take 2 pieces. You end up getting the same amount of pizza. Alright, so as we saw in the warm-up, any number can be multiplied by 1 and not change the value. So that's what we're going to be doing with these fractions, is multiplying by 1. We've also seen that 1 can be written as any number over itself. So we can combine those 2 ideas together. Alright, so we're going to change this to have a denominator of 3. So let's break up 6 and 9, do factoring just like we did yesterday. 6 breaks up into 2 times 3, 9 breaks up into 3 times 3. Now, any number over itself is 1. So 3 over 3 turns into 1. And just for demonstration purposes, you don't have to write this when you do these. Oops. 3 over 3 turns into 1 over 1. And now 2 times 1 is just 2. Any number times 1 is itself. 3 times 1 is 3. So 6/9 and 2/3 are the same fraction. Your turn, number 2. Change 9/12 to have a denominator of 4. So 9 can be broken up into 3 times 3, 12 into 3 times 4. The 3's here will cancel, meaning they turn into 1's. Then multiply straight across. 1 times 3 is 3, 1 times 4 is 4. So 9/12 and 3/4 represent the same fraction. Now what we're going to be doing is reducing fractions to lowest terms. And lowest terms mean that the numerator, the number in the numerator, and the number in the denominator don't have any common factors. In other words, there's no single number that divides evenly into both of them. So we're going to start by simplifying 4/10. Now when you do these factorizations, you do not need to do a prime factorization, but you can if you'd like. You just have to do some kind of factorization. Now sometimes it'll end up being the only way you can do it is by doing a prime factorization. And here's an example of that. When we split up 4, the only way to split that up, other than using 1's, is 2 times 2. And then for 10 is 2 times 5. So the only way we can split it up is 2 prime factorizations like that. All right, now the 2's will cancel, leaving us with 2/5. So 4/10 and 2/5 are the same. Your turn, number 3. So 6 is 3 times 2, 8 is 4 times 2. The 2's cancel, giving us 3/4. Next up, we do 15 25ths. All right, 15 breaks up into 3 times 5. 25 breaks up into 5 times 5. The 5's cancel, leaving 3/5. That brings us to your turn, number 4. $14 is 2 times 7. 21 is 3 times 7. 7's cancel. 2/3. Now these don't all have to be done in one step. Something like this can be done in 2 steps if you recognize that both these numbers are even, so you know you can factor out a 2, like that. 2's cancel, and we get 16 over 20. All right, now we're not fully simplified yet because clearly if both of these are even, they still have more common factors. So we can do this again, but this time I'm going to divide by 4 because I recognize that 4, or I'm going to split it up, I'm going to factor into 4. All right, so those are 4s, common 4s, those cancel and we get 4/5. So it's just fine to do this in multiple steps. We could have done it all at once if we divided both the top and bottom by 8. Your turn, number 5. So we can factor out a 2 in both of these. That gives us 9/15. And then both of these are divisible by 3, so we can do 3 times 3 over 3 times 5. And so 18/30 reduces to 3/5. We have no more common factors, so we're done. All right, next example is 72 over 108. So it can be a little more difficult in this case to see what's going to divide evenly here. It looks like we have a common factor of 6. All right, so we can factor out a 6 in both of those. 6's cancel. And we get 12 over 36. Oh, what in the world am I doing? I knew there was a problem there. It's not times 36. That's way too much. Let's see. I'm a little trouble getting this one in my head. 18, there we go. So we got 6 times 18, that makes more sense. We got 18 on the bottom here. All right, now 12 6 goes into this one as well, so we can do 2 times 6 over 3 times 6 and get 2/3. So that's how we can do it in 2 steps, or if we recognize that 36 divides evenly into both 72 and 1 weight, could have done it in 1 step. All right, your turn number 6. 75 over 175. Now both of these, anytime you got a 25, 50, or 75 or double zeros, you can divide 25 into it. So 25 is going to divide into both 75 and 175. So let's do 3 times 25. And there are 4 25s in 100, plus 3 more for the 75, that gives us 7. So 7 times 25. And that reduces to 3/7. You also could have done that by doing factoring out 5 and then 5 again. All right, so that's one way to do it. Now we're going to look at the division method. And it's basically the same thing, but just a little different way of writing it. So first example is 21 over 35. I personally like the factoring method better because factoring is such an important skill in math. So it's good practice, but this is fine too. So we're going to look at it, and we want to find a number that divides evenly into both 21 and 35. And that's going to be 7. So we'll take 21 divided by 7, and then 35 divided by 7. So make sure you divide both the top and the bottom by the same number. If you divide by a different number, it's going to change the value of the fraction. That gives us 3/5. That brings us to your turn number 7. Simplify 18/21 using the division method. (18/21). Let's see, those digits add to 9, those digits add to 3, both are divisible by 3. Let's try that. All right, 18 divided by 3 is 6, 21 divided by 3 is 7. So 6/7. And we can also do these with multiple steps. You can do as many divisions as you like. So let's take a look at 66 over 78. This one, definitely tough to see the greatest common factor of this. So we'll just divide by, let's see, this is divisible by 3, this is divisible by 3, so we'll divide by 3. Alright, so that is 22 on top, and on the bottom, we've got 26. Alright, common factors here, well, we've got a 2, so we can divide by 2, divide by 2, and that gives us 11 over 13. So 2 steps. Your turn number 8. All right, now both of these, the digits add a 9, which are divisible by 3, so we can divide by 3. So that gives us 15 on top and 18 on the bottom. And now we can do that again. And get 5/6. Next up, we got 48 over 72. So, we could do it in one step, recognizing that 24 divides evenly into both 48 and 72, giving us 2/3. But that might not jump out at you right away. It's kind of a tough one to see right away. But these are both divisible by 3. So we can divide by 3. 48 divided by 3 is going to give us 16. And 72 divided by 3. 24. Now we can reduce this. See, it looks like 8 divides evenly into both of these. So we'll divide by 8 on top, 8 on the bottom, and get 2/3. So same answer either way. Sometimes that's a great check. Do it 2 different ways and see if you get the same answer. Your turn, number 9. Nine to 6 is 15. That's divisible by 3. 3, 4, 5, 6. That's divisible by 3. So both of these are divisible by 3. Gives us down to 32 on top and 44 on the bottom. Looks like these are going to be divisible by 4. Let's try that. 32 divided by 4 is 8. 44 divided by 4 is 11. 8/11ths. Next example, 70 over 126. Let's try dividing by 7. Clearly, 70 is going to divide by 7. And I think 126 does as well. Yep, that's going to give us 18 on the bottom. So we got 10 on top, 18 on the bottom, and then they're both even, so we can divide by 2, so 5/9 for that one. Your turn, number 10. 10 is 60 over 105. Now, if you recognize that 15 divides evenly in both 60 and 105, divide by 15 and get 4 over 7. But if you want to do it in more than one step, both of these numbers end in either 0 or 5, so you can divide by 5. Alright, 60 divided by 5 gives us 12. And 105 divided by 5 gives us 21. Alright, and then divide by 3. And we get 4/7. Alright, so supposedly we're creating equivalent fractions here. So it'd be nice to have a step to see, or a procedure to see if we are correct. We can check our work with the equality test for fractions. This is something that I recommend doing. You can do it very easily and quickly with a calculator, and it's okay to do your checks with the calculator. It's a great time saver. Of course, you can't check with the calculator on the exam, but it's okay, at least you can on homework. equality test for fractions. If we have two fractions that are equal to each other, all right, A over B equals C over D, two equal fractions. All right, then we know that this implies that we can cross multiply. Numerator times the denominator of the other fraction. So that means A times D equals B times C. So if we have two fractions that we think might be equal to each other, if you perform the equality test, it'll tell us whether or not they are. These two things should end up being, these two products should be equal to each other. Example. We're going to test to see if 4/5 equals 11/15. Right, they're very close, but we'll see if they're equal. So we're going to cross multiply numerator by denominator. That's 4 times 15, which equals 60. And then on the other side, we got 5 times 11, and that is 55. So since 60 does not equal 55, that means that these fractions are not equal to each other. Your turn number 11. Let's test these to see if they're equal. We'll put the question mark over the equal sign because we're not sure. All right, so we're going to cross multiply. We got 3 times 35. Right, so we have more digits on top. I like to multiply like this. 15, carry the 1, 105. All right, now we'll do 7 times 15. All right, 5 times 7, 35, carry the 3. 1 times 7 is 7, plus 3 is 10. So 105 in each case. Yes, they are equal. Get rid of that. All right, so that's one way to determine if fractions are equal. Sometimes if you have larger fractions, it may be easier to actually simplify the fraction. So I'm going to test 3/8 and 45 1/20. 3/8 cannot be simplified. Let's try simplifying 45 1/20. So 5 is a common factor, right? We're ending in 5 and ending in 0. So 45 breaks up into 9 times 5. 1/20 is 24 times 5. The 5's cancel. That gives us 9 over 24. Now, 2 plus 4 is 6, so that's divisible by 3. So that means they're both divisible by 3, so that gives us 3 times 3 over 8 times 3. The 3's cancel, and it equals 3/8. Alright, so those two are equal to each other. Now compare the amount of work you had to do there with taking 3 times 1/20 and 8 times 45, and then you can decide which method you'd like to use. Your turn number 12. 5/9 and 30/54. So 5/9 is already simplified. We're going to simplify 30/54. So 30 is 6 times 5, 54 is 6 times 9, 6 is canceled, 5/9. So it does equal the other side. Now sometimes, notice in these cases, one of the fractions simplified to equal the other one. That won't always happen. Sometimes you'll have to simplify both of the fractions. So we're going to do 28 over 70. And 60 over 150. So simplifying these, we're going to do 28 over 70 first. And 7 divides evenly into 28. And definitely divides evenly into 70. All right, so that gives us 4/10. And then we can break that up to 2 times 2, 2 times 5. And so 28 over 70 is equivalent to 2/5. Could have done that in one step if we broke it up into things times 14. Next up, 60 over 150. I'm going to do it 2 steps because it looks like we have an easy one here. 6 times 10 and 15 times 10. Multiplying by 10 is always easy. So that gets us down to 6/15. And both of those are divisible by 3, so we go 2 times 3 on top and 5 times 3 on the bottom and get 2/5. So those are equal and the fractions are equal. Go to number 13. We're going to test 18 over 42 and see if that is equal to 27 over 63. Let's reduce 18 over 42. Those are both divisible by 6. We got 3 times 6 on top and 7 times 6 on the bottom. 3/7. All right, 27 over 63, these are both divisible by 9. So we got 3 times 9 on top and 7 times 9 on the bottom. 3/7. So those are equal. All right, 14, this is a very common exam problem you'll see. You have 3 fractions, determine which pair of these 3 fractions are equal. So we get some fairly large numbers here, so we can start by reducing now 24 over 85. We can break that up into 3 times 8 and 5 times 17. Notice we have no common factors here, so that's not reducible. Let's try the next one. 12 over 42. Both of these are divisible by 6, so we're going to do 2 times 6 and 7 times 6 gives us 2/7. And lastly, 32 over 112. "32 is divisible by 8. It looks like 112 is as well. Looks like we have 4 times 8 and let's see, times 10 gets us to 80. 14. Oops. 14 times 8. All right, so that gives us 8's cancel, gives us 4 over 14. Break that up into 2 times 2 and 2 times 7. 2's cancel, and we get 2/7. So these 2 fractions are equal to each other, and our answer is 12 over 42 equals 32 over 112. Now just to confirm it doesn't equal this one, Notice that if we start from 2/7, I can multiply 2 by 12 to get 24, but if I multiply 7 by 12, I do not get 85. And so that one is not equal to 2/7. So only those two are equal. Now when we do operations throughout this chapter, the answers will always have to be simplified. So this ends up being one of the most important skills in the entire chapter.